Hello everyone, my name is Bradley Sward, and this video today is my solution to day 8 problem for Advent of Code 2023. The problem is called Haunted Wasteland, and I solved the problem in C++. And today we're basically creating a custom binary tree, and we have a ton of nodes here, and basically, or maybe a graph or something like that. It's binary tree or how, whatever. But definitely for every node, it can go down one of two paths. It can go to the left and it can go to the right. And we just have to trust that the data all matches up so that it basically all just works around like a giant maze. And so the first phrase here, RL, basically if we start from AA and I go to the right and then I go to the left, how many times does it take for me to get to ZZ, and in this case, this one solves it in 2 moves. And then this guy here will solve it in 6 moves. If I'm told, if I'm following this LLR, go L, then L, whatever. You can figure it out if you're interested in that. But anyway, so the question is for a giant data set, how many steps does it take to go from AAA to ZZZ? And in my case, the answer is 14,893. But let's take a look at how I arrived at that with my code. And so here is my tree class. Oh, let me just to say here, this is all I'm doing here in my main function. And I'm just saying, let me set up a tree object that I created. And basically, and then I'm going to navigate from AAA to ZZZ. And this is going to be important for part 2. I can definitely see that. It should be pretty good here. I should be pretty good to set up part 2 in a short amount of time. And so I just call the navigate function and it returns an integer value and it just tells me, whatever it's going to be. And in this case, again, it's going to be 14,800, whatever it is going to be. Where's that window coming up? 14,893, which is the answer to my problem. And so I'm going to need nodes for this thing to work because I'm creating up basically a binary tree out of this thing. So for every node, we keep track of its name and we keep track of where does it go to the left and where does it go to the right. And I definitely did not keep track of node pointers and all sorts of stuff like a true binary tree. I just kept track of the string values. Forgive me. It's good enough for what we're trying to accomplish here. It's the same basic principle as a binary tree, but we don't have to worry about newing up memory and just doing all sorts of extra stuff. So just here, and it just needs a little constructor, and it could have been a struct, and so it's not a big deal. But it said, okay, here's my name, here's my left, here's my right. So for every node, and so now in here, my tree class, I have a constructor, I have a function called navigate, and that's about it. I keep track of the string for the order, and I keep track of the map for the tree. So the constructor is pretty simple here. The first line of the file goes into that ordering, the L and the R, and L, R, L, 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 R, 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 L. And so every other line gets parsed a little differently just to make sure we substring it, just to get rid of the unnecessary characters. And we just make sure that we say, okay, the key of my map, every key is a string, and then every value is the node that contains the name, but then also contains what is the left and what is the right side value for the nodes. And so now the only other thing left to do is to set up the navigate function. But basically, I just go character for character through the thing, and I just go, if there's an L, go to the left, and if there's an R, go to the right. And if the name ends up with what I'm looking for, like in this case, I'm looking for ZZZ, and if that's ZZZ, then I'm going to return how many moves it took. Otherwise, I'm going to basically move the ordering around so the first character is always the next character that I want to follow. And it just uses a substring function to do that. And again, it's not the most efficient way of going about it, but it gets the job done. And again, that is what I'm doing for part 1, and I get the answer that I'm looking for. So now I can modify this, and I'll show this here in a second here for how to modify part 2. Okay, and so for part 2, instead of processing one tree structure where we're going from AAA to ZZZ, we're basically going from anything that ends in an A, and then we're trying to figure out if we go step by step by step by step, when will we match up so that all of the different trees that we have from all of the ones that start with an or start with the third letter of an A end with the third letter of a Z. That's basically what we're going here. So and if you just brute force it, it's going to take you forever and a day because These things are absolutely humongous, and I bet, the puzzle makers here made it so that it's basically prime numbers and all sorts of crazy stuff. There's no real divisors here because I know the answer is huge because I have the answer. And so if you just run it basically nonstop, it'll take you a while. I have no idea how long it actually would take, but the number is absolutely humongous. So what we have to do is run each of them individually and say, well, how many steps would it take to get from, like in this case, 11A to 11Z or to 22Z, or just something that ends in a Z, in this case 22Z, or 11Z. And so the same for 22A. And in this case, you can go through down the list here. It would take 6 of them so that they both match up, so that at the 6th step, anything that started with an A is now sitting on anything that starts with a Z. And so what we have to do basically is we run them individually, and then we run the least common multiple, or the least common multiple of all of them, of all the values, to figure out what that answer is. So you only have to do this a few, maybe 100,000 times or something like that, rather than 9 quintillion or whatever the heck the number might end up being. So let me show you the code, and then you can see the answer here. I used the long data type because I had to. And so now this is, I rewrote my navigate function to handle the fact that I need to go through every current one individually, and that's what you get here. And then here's the least common multiple. And since I'm still running on an old compiler that I need to fix up on, here is the functionality to do that. Basically, this is what the library does anyway. So here's the GCD function, and that's used by the LCM function. And so the LCM is what you get here. So basically, what am I doing here? I'm going through every node in my tree, and I'm finding all of the ones whose third letter is an A, and I'm putting it into a list, or a vector in this case. And so now I'm going to keep track of all the answers as they come along. And so I'm just saying, for every node that starts with an A, go through and figure out how many steps it takes to get to a node that ends in a Z, and keep track of that value. So basically the same process as the first part, but again, it's just a little more complicated here. So for every one of these, go left, go right, go right, go left, and so forth and so on, until you reach that Z as the third character in whichever node you're currently in, and then you add that number to the list and you start over again. Otherwise, and again, it's the same thing where I'm moving the list around and doing all sorts of stuff. And I do that for round by round by round for every one of them. And when I get to the end here, then I run the LCM of all of them. And the least common multiple will get me there. And you can see how long it takes me to run this. It only takes, let's see, 1, 2, 3, 4, 5. They're in about 5 seconds there. There's my answer that, my large giant answer that ends in a 509. And you can see here my answer ends in that giant same number, ending in a 509. So there you go. So that is my solution to day 8 of the Advent of Code competition. As always, these problems are fun, still doable for me in a reasonable amount of time, within a couple hours. I'm just having fun. I'm not really rushing to get these things done, but I know I beat quite a few of other people to basically I beat the 2,500 people who got part 1 just like me. So that's great. I had some fun doing it. So as always, if you know a better way, or if you'd like to comment below, as always, I'd appreciate it. I hope I taught you something for those of you who are watching for that purpose. And I hope to see you guys all in future videos. Thanks. Have a great day. Have a great night. Have a great morning. We'll see you then.